Continuing our discussion from section 6.3 in part 2. Here, now we're using reference angles to help us evaluate. So here, if I have 16, or sine of 16 pi over 3, then I need to first change my 16 pi over 3 into, so it's in between 0 and 2 pi. Just like I did for the previous 870 in the last example. So 16 pi over 3 needs to be subtracted by 2 pi. Remember, that's the same thing as 6 over 3. So that gives me 10 pi over 3. I need to do it again. So 6 pi over 3 gives me 4 pi over 3. Okay? So sine of 16 pi over 3 is the same thing as asking what the sine of 5 or 4 pi over 3 is. Okay? So from here, now I need to be able to use my reference angle. Okay? Now how I use my reference angle here is, okay, I need to first locate what quadrant I'm in. So for 4 pi over 3, if you think thirds, here's 1/3. 2/3 is right there, and then pi is the same thing as 3 pi over 3, so then the next one has to be in the third quadrant. Okay, so sine of 4 pi over 3 would be in the third quadrant. Okay, so if I'm in the third quadrant, then I need to take t minus pi, because 4 pi over 3 is greater than pi. So 4 pi over 3 minus pi, which is the same thing, like I said, as 3/3. So it gives me a reference angle of pi over 3. Okay. Now, sine of 4 pi over 3 is not the same thing as sine of pi over 3. Because when we're looking at our unit circle or our coordinate plane, pi over 3 is in the first quadrant where sine is positive. 4 pi over 3 is in the third quadrant where sine is negative. So what I need to do here is I need to change the sine value, or the SIGN sine value of sine. Okay, so then I need to tack on a negative sign onto my sine. So now negative sine of pi over 3 is the same thing as sine of 4 pi over 3. So then, since I know what my values for pi over 3 are, I can take negative times the value of sine of pi over 3, which is square root of 3 over 2. So then that means negative square root of 3 over 2 is the ratio value for sine. If I try this with secant, okay, if I have secant of negative pi over 4 here, I need to once again get it in between 0 and 2 pi. So since it's negative, I need to add 2 pi to this instead of subtracting, which is the same thing as, since we're talking about fourths, same thing as 8 pi over 4. So then that gives me 7 pi over 4. Okay, so secant of 7 pi over 4 is what I need to find. Now, here, I don't really quite know what my secants are yet. Okay, but I do know what my cosine values are if I have my my reference angles. And I guess we did also write down our secants. So if you knew the secants for pi over 4, then kudos to you. So here, I need to find the reference angle of 7 pi over 4. That is in the fourth quadrant, because if I have, go around, I start with 0, I go 1 pi over 4, 2 pi over 4 is a half, 3 pi over 4, 4 pi over 4 is a pi, 5 pi over 4, 6 pi over 4 is the same thing as 3 pi over 2, and then 7 pi over 4. Okay, because then the next one would be 8 pi over 4, which is 2 pi. Okay, so then that's in the fourth, so then taking 2 pi minus 7 pi over 4 to find that value. Remember, that's 8 pi over 4. So that's pi over 4. So secant would be the same thing as, or secant of 7 pi over 4 would be the same thing as secant of pi over 4. Now here, think about your trig values. Pi over 4 is in the first, so everything's positive. But since we're talking about secant, that's the same as cosine, and cosine is positive in the fourth, so therefore secant is positive in the fourth, because your x value is in a positive direction. So therefore we don't have to tack on a negative sign to our trig function for secant. So these two things are equal to one another. So now I know what my cosine value is. So cosine of pi over 4 is square root of 2 over 2. Okay, so then secant of pi over 4 is going to be the reciprocal of that. So then it'd be 2 over square root of 2. Okay. Then here we would need to rationalize, which we did in section 1. So then that gives me square root of 2 over 2, which reduces to square root of 2. Okay, so then that would be the ratio that I would use to express what the secant of negative pi over 4 is. So then now, let's say I give you tangent of theta is equal to 2/3, and that is in the third quadrant. Find the other trig functions. So here, we're in the third quadrant, so I need to draw my triangle. Remember, when you draw your triangles, okay, or any reference angle values, always draw them so that one side that has the right angle is flat with your x-axis, okay, and your angle is coming from the origin, okay. You can't have a picture that looks like this because your values will be off. So don't do that. Okay? Okay, so here if tangent is 2 over 3, if you think about either opposite over adjacent or your y over x value, okay, this side is our y, okay, so then that means the top number is 2 here, and then the adjacent side, or the x value, is 3, which would go here. Now, think about third quadrant. We're negative in the third quadrant, so both of these are written as positive, but we need to change their sign to be negative, because when you divided them and put them in tangent, negative divided by negative made it positive, so that was the more simplified version. Now I need to be able to find what my radius is, so I need to take the Pythagorean theorem of this. So negative 2 squared plus negative 3 squared equals r squared. So 4 plus 9 r squared gives me 13. If I square root, that gives me square root of 13 equals r. Okay, so then my radius is square root of 13. Now, radius is always a positive value, so don't think that you have to use plus or minus in this case. So now I need to find the other trig values. So sine of theta will be my opposite over my hypotenuse. So negative 2 over square root of 13. Rationalize. That gives me negative 2 square root of 13 over 13. Cosine theta will be negative 3 over square root of 13. Rationalize. It gives me negative 3 square root of 13 over 13. Then I already have tangent, so moving on to cosecant. Remember, it's the flip of sine, so that's actually square root of 13 over negative 2, so I don't have to rationalize there. Secant So it's the flip of cosine, so that's square root of 13 over negative 3. And then cotangent is the flip of tangent, which we said was 2 over 3, so that's the same thing as 3 over 2 for cotangent. Okay? So then that would be all my ratios. Moving on. Now the last little bit of this, they add in the section they talk about the area of a triangle. They give you the formula where area is equal to 1/2 times A times B times sine of theta. A and B values are the values or the sides of the triangle that make up the angle that they're talking about. So here our A and our B are 4 and 11 because they make up the angle of 120, which is the only angle we know. So the only way to find the area of the triangle given this information as of right now is to plug it into this formula. So I have 1/2 times A value of 4 times the B value of 11 times sine of 120. Okay, so now 1/2 times 4 gives me 2. Okay, now I want to change or use my reference angles to help me out with the 120. So 120 is in between 90 and 180, so that means I need to take 180 minus my t value, which is 120 in this case. So 180 minus 120 gives me 60 degrees. So then sine of 120 is the same thing as sine of 60, and because they are both above the x-axis, that means that they're both positive, so you don't have to tack on a negative sign to the sine of 60 to keep it the same. So now sine of 60, we know that to be square root of 3 over 2, and 2 times 11 is 22. Okay, so then I can reduce. That gives me 11 square root of 3, and since I'm talking about area, I'm going to write it as units squared. Oh, sorry. We're actually given a label here because our sides are in centimeters. I would say centimeters squared. Okay, and then that would be my answer. Have fun.